What's up folks, Raj here, back with another Kubernetes interview question and answer video. A lot of you said my previous videos, the questions were a little bit moderate to advanced and you wanted me to cover some must know questions more on the basic level. So in this video, we are going to do that. So these questions are must know, like I said, so make sure you study these either from this video or externally. So questions we are going to cover today are, is Kubernetes the only container orchestrator? Name another container orchestrator from AWS. Why should you choose EKS or Elastic Kubernetes Service? Tell me the high-level workflow of microservice in Kubernetes. What is the difference between horizontal pod autoscaler and cluster autoscaler? What is the difference between cluster autoscaler and Karpenter? What is the difference between Daemonset and sidecar? What are Kubernetes control plane components? Name some tools which can monitor Kubernetes. How would you do Kubernetes logging? What is EKS Addon? Name some EKS add-ons. What is the difference between ingress and service? Name a couple things you do and do not like about Kubernetes. What is a multi-stage build? And finally, now that Docker Desktop charges money or it has a license, paid license, will that impact your Kubernetes workload? So the last one is a trick question, but make sure you know the answer. Just a quick announcement. All my Cloud DevOps courses on Udemy are on sale. So you can get the maximum discount possible, but this is only for next 4 days. The best way to get the discount is go to my website, cloudwithraj.com. And once you are there, you can click this banner, Spring Sale on all Cloud DevOps courses, or you can simply scroll down and under my top courses, you will see all my courses listed. So if you are interested in learning about Git and GitHub, system design, Kubernetes, serverless, CloudFormation, you can simply click this discounted Udemy link and it will open up the Udemy page along with the discount coupon already applied. I'll give the link in the description. All right, let's get back to the video. So question number 1, is Kubernetes the only container orchestrator? The answer is no. There are many other orchestrators such as Apache Mesos, Docker Swarm, etc. What is another container orchestrator from AWS? Amazon ECS or Elastic Container Service. Next question, why should you choose EKS or Elastic Kubernetes Service? So basically interviewer wants to see if you know the advantages of EKS. The first one is EKS is upstream and certified conformant version of Kubernetes. So this is like a fancy line. What it means is if you are running Kubernetes today with some open source Kubernetes tools, maybe you are running this Kubernetes workload in on-prem or another cloud, the EKS is a certified conformant version. That means you can bring your existing workload as well as the tools you are running today on Kubernetes elsewhere to EKS without any problem. EKS also supports 4 versions of Kubernetes at one time. So currently it supports version 1.22, 2.1, 2.0, and 1.9. So this gives you sufficient time to upgrade to the next version. The biggest advantage of EKS is Amazon manages the control plane for you. So currently, if you are managing the Kubernetes yourself, you know the biggest pain point is to manage your control plane to make it highly available and scalable. Some of the component of control plane is very critical, such as etcd. So if you lose etcd, you will lose the whole cluster. With EKS, AWS runs the control plane in 3 different availability zones, including etcd. Also, as the cluster grows in size, Amazon EKS will automatically scale the control plane so that you don't experience slowness. Another thing to keep in mind is each EKS cluster has its separate and dedicated control plane. Even if you are running multiple clusters, the control planes are not shared. Next big advantage, with EKS, customers have less management overhead. So when you say this, expect the interviewer asking you why or how. So you have to name a couple of these big features such as managed node group. With managed node group, you can upgrade your Kubernetes version for the worker node with one click of a button or one API call. And while it's upgrading the worker nodes, it will keep your application up and running. So it will do a rolling deployment and it will respect the pod disruption budget. What that means is if you specify a certain percentage of pods to be up and running, this managed node group will do that for you. Second advantage is managed add-ons. So when you run a Kubernetes cluster, you have to install some additional software for your production workload. With EKS, some of the add-ons are managed by AWS. So AWS gives you the software to install. If something needs to be upgraded, AWS gives you the upgraded copy. And also if something goes wrong, you can open an AWS support ticket and AWS will help you fix it. Some of the examples of managed add-ons for EKS are VPC, CNI, ADOT, etc. And the other big advantage is for your worker nodes, EKS provides the AMIs. Creating and maintaining an AMI is a painful task, especially if there is a security vulnerability. You have to fix it yourself. With AWS provided EKS optimized AMI, AWS gives you the AMIs, it fixes security vulnerabilities, and you can just grab the AMI and use it directly. Amazon EKS is cost effective. It costs 10 cents per hour for the control plane, and the data plane cost is based on what kind of EC2s you are using and whether you are using Fargate. This is also eligible for savings plan. So if you have a contract with AWS, the cost will come down even further. And the last but not the least, mention this point because not many interviewees are going to mention this. Say that other large-scale enterprises running EKS, so EKS can be trusted to run secure and large workload. Some of the publicly referenceable examples are HSBC Bank, Amazon, and Snapchat. I like to give these three examples because HSBC Bank exemplifies that it can run secure workload, and Amazon and Snapchat, the volume is crazy, so it demonstrates that EKS can handle very high traffic. The next question is, tell me the high-level flow of microservices. So I'm going to give you the high-level flow of how things get deployed into Kubernetes and then the microservices. So your developer checks in the code and the Docker file in a repository, and then you create the container image using this Docker file, and then this container image is saved in a container repository. One example would be Docker Hub or Amazon ECR. And then from this Amazon ECR, this container will get deployed into a Kubernetes cluster. So let's say, for example, we are using Amazon EC2 for worker node, and then you will use a Kubernetes deploy to deploy the container into the running EC2s. The container image don't just run by itself. It is encapsulated by pod. So the pod is the smallest deployable unit in Kubernetes. So when it needs to scale, the container image just doesn't scale by itself. The pods needs to scale first. But then how will this pod get exposed to outside world? So you will use Kubernetes service, and with a specific kind of service such as load balancer, anyone from outside the Kubernetes cluster can call this. So this is essentially a microservice. Next question, what is the difference between horizontal pod autoscaler and cluster autoscaler? This question can be alternatively asked, can you tell me how will you scale your workloads in Kubernetes? So the way it works is, as traffic increases, the CPU and memory utilization of pod goes up, and then you use HPA or horizontal pod autoscaler, and for horizontal pod autoscaler will dictate at what percentage of CPU or memory usage you will create another pod. So I'm just saying CPU and memory because those are the most commonly used parameter. But using other tools such as SCADA, you can also use other metrics other than CPU and memory. But anyway, coming back, so using horizontal pod autoscaler, you create another pod in the same Amazon EC2. But remember, Amazon EC2 also have CPU and memory. So at a certain point, after a certain number of pods spin up in this Amazon EC2 instance, the CPU of this Amazon EC2 reaches a critical threshold, and using cluster autoscaler, you spin up additional Amazon EC2s, and then more pods could be scheduled in those Amazon EC2s. Horizontal pod autoscaler and cluster autoscaler is a big topic, and you should know this in detail. So I have separate videos going over HPA and cluster autoscaler. I'll give the link up top. So please make sure you study those, either from my videos or you can study yourself externally, but make sure you study those before going to interviews. Next question is, what is the difference between cluster autoscaler and Karpenter? So regular cluster autoscaler without Karpenter just spins up a similar EC2 node. So basically EC2 M5 large, it keeps spinning up whenever there is a pod that needs to be scheduled, it spins up. But let's say a new type of workload comes into the cluster and this requires some GPU EC2. So regular autoscaler will not be able to schedule that pod. And the way around is you have to create a different compute node group. So basically you'll have a node group for M5 large, another node group for GPU, and once you do that, then another GPU EC2 can come up and GPU workload will get scheduled. With Karpenter, you don't need to create this separate kind of node groups. Not only it can spin up any kind of EC2 without the need of you defining different node groups, but also it can resize the instances. It's not stuck to just EC2 M5 large like previous example. If it makes sense to spin up a, let's say C5 2x large and fit all the pods in there, it can do that as well. Next question, this one is very important as well. What is a Daemonset and what is a sidecar? Or you could be asked, what is the difference between Daemonset and sidecar? So Daemonset ensures that all the nodes of your Kubernetes worker plane run a copy of a pod. Whenever you get this kind of question, always give an example. So one example of Daemonset could be FluentD or FluentBit for logging. So every worker node of your Kubernetes cluster will run a pod for FluentD or FluentBit, and then for FluentD, FluentBit is used for logging, and then it will gather the logs and then send it out to your logging system. Whereas sidecar is another container will run inside a pod alongside your application container. So one example of sidecar is Istio. Because Istio controls traffic, it needs to sit right by your application container to work as a proxy. So the next question is, what are the Kubernetes control plane components? So the control plane has the following components. The API server. So API server is the component of the Kubernetes control plane that exposes the Kubernetes API. So think of it as whenever you are running a kubectl command, it is actually going to the API server. So that is the part of the Kubernetes cluster that's exposed to you. So the next part is etcd. So etcd is like the hard disk of your Kubernetes cluster. It's a consistent and highly available key value store used as Kubernetes backing store. So basically this etcd saves your Kubernetes secrets. Also it stores how many nodes are running, what workload running in what nodes, etc. So if you lose etcd, you're gonna lose the cluster. So that's why Amazon EKS runs 3 copies of etcd in 3 different availability zones in its control plane. etcd is not Kubernetes specific. It is also an open source, consistent and highly available key value store. Kubernetes just adopted it to be used with Kubernetes. Next one is scheduler or kube scheduler. So this is the control plane component. Whenever you need to create a new pod, so let's say you do a kubectl apply and then a deployment, and then the scheduler schedules the pods. So it goes and checks which worker node has capacity, and then it schedules that pod. If there are no more capacity in the worker node for that pod, it interacts with autoscaling groups or Karpenter and then spins up new node. So that's what scheduler does. It also understands things like affinity, anti-affinity, data locality, etc. So the next component is kube controller manager or controller manager or controller. So this is the component that ensures that the desired state of the cluster is matching with the current state. So my favorite example that I use is a replication controller. So let's say you deploy a deployment and the pod should have 10 replicas, and for some reason 2 replicas go down. So the replication controller keeps on checking what's the desired state, and the desired state is listed in etcd, and the current state now deviated from the desired state. So the current state is 8 pod, desired is 10. So the replication controller will kick in and then work with the scheduler to schedule 2 more pods. So similarly, there are different controller, node controller, job controller, endpoint controller, etc. Each of these controls the desired state matches with the current state. So the last one, it is additional if you are running Kubernetes cluster in the cloud. So let's say for AWS, because with the cloud, there are some cloud specific concepts such as the nodes or Amazon EC2s. So for the node controller for EKS, checks with AWS to determine if a EC2 instance has been deleted in the cloud after it stops responding, what should the behavior be, etc. Similarly, for service controller, let's say you are using load balancer service. So basically, it has to interact with AWS Elastic Load Balancer. You got the idea. Even though this question was about control plane components, but also study the node components as well, especially kubelet and kubeproxy. I'll give the link in the description, or you can just Google Kubernetes components and this official Kubernetes page should come up. Next question, name some tools which can monitor Kubernetes. So whenever someone talks about monitoring, always think of metrics and alarms. So metrics could be the metrics for CPU, memory, or some application specific, such as how many connections or traffic, and then based on that, alarm. So the most popular monitoring tool is Prometheus. And so Prometheus collects all the data in a time series format. And then using Grafana, you can create metrics on top of it. Prometheus also has a component called Alert Manager. And using Alert Manager, you can send alerts, such as if the CPU utilization of a particular node goes to 95%, etc. I have a separate video on Prometheus and Grafana, so please check them out. This is also a very important topic. Now, if you want to impress the interviewer, you can mention AWS Addon or AWS Distributed Open Telemetry. So whenever you use Prometheus, the open source Prometheus, you have to grab the package, install it yourself. With Addon, it's a managed add-on, so AWS gives you the total software. And the biggest advantage of Addon is Addon not only does monitoring, but it can do tracing as well. Addon integrates directly with Container Insights. So instead of using Prometheus, you can use Container Insights, and Container Insights already have the metrics built in. So you don't have to go define metrics like you have to do in Grafana. And also Container Insights server is managed by AWS. So even if your cluster scales like crazy, AWS will scale the Container Insights infrastructure to keep up with it. Which goes in nicely with the next question, how do you do Kubernetes logging? You could have FluentD, FluentBit, those are the very popular Daemonsets, and FluentD, FluentBit can collect the logs and send it to your preferred choice of logging solution. You can send the logs to CloudWatch Logs, or you can send it to third-party logging systems such as Splunk, Elasticsearch, etc. Next question, what are EKS add-ons? Name some examples. So when you provision a Kubernetes cluster, since it's open source, you also have to install some additional software for different functionality. I just mentioned FluentD, FluentBit for logging, Prometheus for monitoring. So you have to install all that stuff. Those are what we call as add-ons. Now some of the add-ons, AWS manages it, and in this diagram you could see such as VPC CNI, Core DNS, EBS CSI, kubeproxy, as well as recently released Addon. But some of the add-ons you need to install yourself, such as if you are using Traffic as ingress or Nginx, Helm, Argo CD, etc. So I wanted to mention here, in case interviewer asks, so this is a lot of overhead of installing all these add-ons, what is the best way to handle this? So you could say that the newly released open source project from AWS called AWS EKS Blueprints gives you complete examples and Terraform modules to provision cluster with all the add-ons, along with the security best practices built in. So for example, this complete Kubernetes add-ons gives you the Terraform to spin up Kubernetes cluster along with installed add-ons, right? So which is pretty amazing. If let's say you want to use crossplane, so it gives an example, it brings up a EKS cluster and it installs crossplane. AWS keeps this repository up to date. As EKS gets upgraded or new tools and features come in, AWS will keep this repository up to date. I'll do a separate video on this going over with a demo, so keep an eye out for that. Next question, what is the difference between ingress and service? So I went over how does a microservice architecture looks like in answer to a previous question. So check it out if you haven't. Now, extending that concept, so the way service is implemented for external facing microservice is using a load balancer. So each service will have its separate load balancer. So if you have 3 different microservice, let's say /browse, /buy, /refund, you'll have 3 different load balancer, and each load balancer will have a separate URL. So the disadvantages of services, it's expensive to maintain 1 load balancer per service because now you have 3 load balancers. No URL based routing because each load balancer will have its own separate URL. If you want to use a common URL and then /browse, /buy, /refund, you have to have a global load balancer on top of this 3 load balancer, which adds even more cost and maintenance. So there is a maintenance overhead of managing separate services. So AWS Ingress solves that challenge. So AWS Ingress is an object where it can do path-based routing, and it can route traffic to different pods for different URL, and it uses 1 load balancer. In this case, the traffic for 3 different microservices coming to the same AWS Ingress, which means 1 elastic load balancer, 1 URL. It can use the URL-based routing, and they're routing to different pods for these 3 different microservices. So I have a separate video on Ingress, so please check it out. I'll give the link up top. So next question is, name couple things you like and do not like about Kubernetes. I like this question because it kind of shows that you have actually tried Kubernetes hands-on and not just read theories. So I'll name 2 advantages and disadvantages. So the biggest advantage of Kubernetes is portability. If you are running a Kubernetes workload today in on-prem and you want to move to Cloud A tomorrow or maybe AWS the next day, you could do that. All the workload and the container image and the tools you are using, you can just carry them over. Next biggest advantage is the open source and vibrant community. So whenever you need an example of something for a specific microservice, or maybe how to use a specific CNCF approved add-on, there are so many examples. So it's very easy to find a proof of concept and then try it out. Another advantage, even though I said I will give you 2, is you can choose the underlying infrastructure. Let's say you are running Kubernetes in virtual machine and your workload is a GPU intensive workload or maybe memory intensive. You can choose the infrastructure based on that. In some of the services, let's say AWS Lambda, you can run your microservice, but you cannot choose anything other than the memory. You don't have any way to choose whether you can run the Lambda in a GPU infrastructure or not. Kubernetes, you can change the infrastructure based on your workload. Now, a couple of disadvantages of Kubernetes is the steep learning curve. Because if you're running Kubernetes on cloud, you have to learn the cloud components that's there, but that's not enough. You also have to learn Kubernetes concepts. So for example, if you want to scale Kubernetes pods, you need to learn Kubernetes concepts like horizontal pod autoscaler, metric server, cluster autoscaler, and you also have to learn AWS components. So it kind of, the knowledge curve is a little bit steep. Second disadvantage is because it's so flexible, the day 2 operation could be a challenge. Kubernetes has a lot of moving components, and for each functional area, you will install some sort of open source tool like FluentD, FluentBit, Prometheus, Traffic, etc. So when it breaks, you also have to know how to fix in the day 2 operation. So when you mention this, the interviewer might ask, is there any way to reduce this pain? Yeah, a couple of ways. One is you can use the EKS blueprints that I showed, which kind of installs all the add-ons From the day two operation side, you can use tools like Rancher, Rafe, which makes your day two operation a little bit easier. Next question, what is a multi-stage build? If you look into a Docker file, you can see that each line is a command. So when these commands are executed, it creates a layer or intermediate images. For example, when the from Python 3.8 is run, it creates a layer for this command. Similarly, each commands keep on adding more layers to the container image. And your final Docker container image is the collection of these layers. You want the size of your container image as low as possible, and to do that, you should reduce the number of layers. How do you reduce the number of layers? So if you think about it, at the end of the day, all the Docker file is doing is, it is taking your code, installing the dependencies, and compiling it, and then creating an executable. And once you have this executable, it can run anywhere, right? Because once you have this exe file or a jar file or the Golang final package file, you do not need to have the code and dependencies anymore. That final artifact is able to run by itself. So your final Docker container image can just have this final executable artifact, and you should be fine. So multi-stage build achieves that. So with multi-stage build, you can have multiple stages in the same Docker file. So let's say stage 1, you have the large base image, and then you install the code and dependencies, and then you compile your code to an executable artifact. And on the second stage, you take the small base image and just copy the executable into that small base image, and you create the final Docker container for your application from this next stage. And all these multiple stages can be done in the same Docker file. So let's take a look at an example. So if we look at a multi-stage Docker file, so on stage 1, it is grabbing the Golang version 1.7.3, and this as builder is the name of the stage. So the name of the stage is builder. And the final line of this stage, it is compiling the code and creating the final artifact. Now in the same Docker file, you can see we are grabbing the lightweight image, and anytime there is a from statement in the Docker file, that means a new stage starts. And in this stage, I am simply copying the compiled code from builder stage. You can see I am referring the previous stage with -- from equals to builder. And the Docker container image will only be built from the last stage. So in this case, if you created your Docker container from just stage 1, the size will be much larger. But on the second stage, since we are using the lightweight image and only copying the executable artifact, the size will be much less. Last question, now that Docker Desktop charges money, will that impact your Kubernetes workload? So the answer is no, and the interviewer might ask why. So basically, all the container runtime is built based on Open Container Initiative. So this specifies the image specification. So once you have a container image, it should run on any container runtime that is compliant to OCI. So think of this like a Swagger file for API. Once you have a Swagger file, you can run it in any API management platform. Good thing is the Docker is a container runtime. It is OCI compliant. So is containerd and CRIO. So even if you created your container image using Docker file, that has nothing to do with the container runtime. So the container image will become OCI compliant. So this container image can run on any OCI compliant container runtime. So Amazon EKS uses containerd as the container runtime. That's also OCI compliant. So your workload should run fine in Kubernetes. The only thing that's impacted by the Docker desktop license is the local machine features, like you could spin up a Kubernetes cluster in a local machine, some of the security features, etc. You can look up the alternatives. There are a bunch of alternatives on Docker desktop, so you can Google that, or I have a separate video on that. You can check that out as well. Hopefully this video was helpful in your interview preparation or in general Kubernetes studying. Please click that subscribe button. Only 15% of you are subscribed to my channel. I regularly create content like this for your interview preparation, Kubernetes deep dive, demo, serverless, DevOps, etc. Also, if you are looking to learn Kubernetes, system design, serverless infrastructure as code, check out my best-selling and highest-rated courses in Udemy. There is a special Mother's Day sale going on. I'll give the link down below. That helps this channel grow as well as helps me create more content for you. Alright folks, that's it for this one. I'll see you guys and girls in the next video. Bye.